Alright, boys and girls, welcome back to the drive-thru. Hope everyone's having a wonderful Thursday. This lesson is brought to you by the deli. Hungry? Stop by the deli. Get yourself an O.J. Simpson Chase t-shirt. Alright, so this is another lesson that's a review for you guys. So hopefully this is kind of seeming like a good chance for you to get caught up with your understanding. Maybe you remember that the distance formula, okay, I should write it out. The distance between points A, which is x1, comma y1, and B, make these capitals. And what are we going to call B? x2, comma y2 is dot, 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 and then B equals. Okay, look, don't get confused by this notation. We're just saying if we have any 2 points in the coordinate plane, to find the distance between those points, you subtract the x values, and then you square that, and then you subtract the y values and square that, and then you take the whole square root of it. You could also have x1 minus x2. What would that do to that number in the parentheses? It would make it negative, or it would make it positive, right? But then when we square it, what happens? It becomes the same number, so it doesn't matter. In slope, order does matter. In distance formula, order doesn't matter, okay? In slope, order kind of matters. How can I just leave it at that? Okay, so let's do a couple examples. Find the distance between these 2 points. So, just so you understand what we're doing, let's go ahead and plot these bad boys. 6, comma 2, negative 1, negative 8. Okay? We're trying to find the distance between point A and point B. So, distance is square root of 6 minus a negative 1 squared plus 2 minus a negative parentheses 8 squared. So it's the square root of 49 plus 100, radical 149. 4 doesn't go into that, 16 doesn't go into that, 9 doesn't go in that, 25 doesn't go into it, 36 doesn't go into it. If 36 did, 9 would. 49? Nope. That's it. That's your distance, I think. Okay? So far, so good? Do we need plus or minus on these? We don't need them on any of them. Why? We're talking about distance now. It's weird. We're toggling back and forth between the algebra world, where negatives often happen, because algebra represents more of a positional or a monetary system, where negatives happen all the time. It's called debt. And geometry represents lengths, and lengths aren't negative. It's weird. Okay. Next example. Find the distance between the points 6, comma 5 and negative 3, comma 5. 6, comma 5 and negative 3, comma 5. We're looking for that distance. Distance is the square root of 6 minus a negative 3. 6 plus 3 squared plus 5 minus 5 squared. So it's the square root of 9 squared. So it's the square root of 81. Now let's see, is that a perfect square? Yeah, and I'm just annoying you on purpose. On purpose. Somebody yelled at 9 before we started. How'd you do it? It's horizontal, right? That's what you said. So you just used what? What mathematical process did you use to find the answer? You used subtraction. You don't know it. You said addition and you said count, but what you actually used was subtraction, whether you know it or not. If you said addition, then what you did was you subtracted a negative, which is why you added. If you said counting, then you used addition, which is just a form of subtraction. So it's subtraction. Do you know what I mean? This is 9. This is 9. It is 6 minus a negative 3. Well, why am I wasting your time with this? Because I don't think all of you guys fully understand this. I think to some of you, you're like, geez, it's another thing we got to memorize. No. What is this? It's the Pythagorean theorem. That's all this is. Okay? So if I have some point here and some point here, and I call this point x1, comma y1, and I call this point x2, comma y2, what is this length of this pink line right here? Well, let's figure out, what's this point right here? What is this point? You can figure it out. It's x2, comma y1. Excellent, Serby. So what is the distance of that pink line? It's x2 minus x1. Don't you agree that? You just told me the last one was 9. It's the exact same problem. Do you agree? And what's the length of this line? That would be y2 minus y1. Actually, it would be y1 minus y2, but it's okay. This green number is going to be negative right now. And then how would we find that black line? You would use the Pythagorean theorem. So you would just say x2 minus x1 squared plus y2 minus y1 squared equals, now we'll call it h for hypotenuse, but our hypotenuse represents what? What's it represent? It represents the distance between the points, does it not? So the hypotenuse is the distance. And how would I get rid of h squared? I would square root both sides, and now hopefully you understand where the distance formula comes from, and you'll never ask anyone again, certainly never juggle what the distance formula is, because you understand it. You should have this in your toolbox, and you should keep it for the rest of your life, because it's very simple. Everybody got it? Can I get an emphatic boom if you feel like you understand this better than you once did? Oh, that wasn't emphatic.